Algebras. Welcome to your Chapter 11 exam review. So I'm going to go through and do a couple of problems and then pause it and have you try a couple of problems, and we'll make sure you're nice and comfy for your Chapter 11 exam tomorrow. So here we go. Let's start out by finding the axis of symmetry and the vertex and whether it's a max or a min algebraically from standard form. So remember, we've got these two forms of our quadratic functions, our two different forms that our quadratic functions can take on. Y equals ax squared plus bx plus c is standard form, and y equals a times x minus h in parentheses squared plus k is vertex form. And so when you've got standard form, you need a different equation to algebraically find the axis of symmetry and vertex. And that equation is x equals negative b over 2a. So this is the formula that helps us find the axis of symmetry by algebra for our standard form. And notice, by the way, it's the negative b, so the front and bottom of the quadratic formula. So if you cut out the discriminant, the plus and minus square root of b squared minus 4ac, if you cut that out, this is how you find the axis of symmetry equation. And it's an equation because it's always a vertical line, so it's always x equals, and it's always what cuts the parabola in half. So let's use that right here. Our axis of symmetry, we'll use x equals negative b over 2a because we have standard form of our quadratic function. And we plug in negative of negative 4, because that's our b value right here, divided by 2 times 1, because that's our a value right here. And we get 4 over 2, which can divide and reduce to 2. So x equals 2 is our equation of axis of symmetry. We always have to state it as an equation, and it's always x equals. Next, I use that x value because the coordinates of the vertex is always on the axis of symmetry line. It's that turning point. It's where your parabola turns back around. So if I use this x value plugged back into the original function equation, I can find the matching y. So y equals 2 squared minus 4 times 2 plus 1. And if I just show that substitution in, then I can actually come over to my graphing calculator and I can plug that line of work in. So parentheses around 2 and then square it, and then minus 4 times 2 and then plus 1, and we get negative 3. So our y value is negative 3 when our x value is 2. That means the coordinates of the turning point or vertex are 2, negative 3. And we put those in parentheses with a comma between them. Lastly, I can just circle max or min. So I can tell that this is a smiley face parabola, and just sketch it. Smiley face parabolas have a bottom. So this is a minimum. And how can I tell it's a smiley face parabola? Because this is a positive x squared, right? Okay, so now I want to point something out about number 2 and number 3, both of which I'm going to pause this and have you try. Number 2, the value missing is c, so that means c equals 0. But in number 3, the value missing is b, so that means b equals 0. So when you go to plug that into the axis of symmetry, keep that in mind, okay? So I'm going to pause it right here so that you can try both of these, and then we'll come back with answers in a second, but I really want you to make sure you pause and give it a try yourselves, okay? Be right back. Okay, let's check your answers here. See how you did? Remember, I gave you that hint that the b value was going to be 0 here. You can't have a negative 0, obviously, but if 0 is your numerator, then the whole fraction is worth 0. You have none of the 4 parts there. So that just tells me that the y-axis is actually my axis of symmetry in this case. And that means that the y-intercept is also my vertex or turning point. So the y-intercept here is 0, 8. So that means that 0, 8 is my vertex, and it's a minimum point. Oh, Sorry, you can't see that. I circled minimum. Okay. Whereas up here, it was just the C value that wasn't present. So you do still plug in the 3 in both spots to figure out your vertex coordinates. Okay. All right, moving forward. Let's look at the next type of question where you're given a graph and we need to state the characteristics given a graph that's already done for you. So points plotted in the whole thing. So let's say the equation of the axis of symmetry is the equation of the line that cuts the parabola in half. And it's always x equals, and you always figure it out by drawing in that line as a dashed line. And wherever we're touching the x-axis, that's how we know what the equation of the axis of symmetry is. So it's x equals -2. Never write just -2. It's got to be x equals -2. Okay, it's got to be written that way. The vertex is always the point with the exact same x value on that parabola. So this x value that is a minimum, by the way, is -2, -16. So way down here, this is going by 2's, right? So this is 16 right here. So -2, -16, and this is a coordinate point. So we put it in parentheses with a comma between. Of course, the min, just circle. You don't have to write it out. It is the bottom. And the zeros are where the parabola touches or crosses the x-axis. So in our case right here, the zeros are at 2 and -6. Now for this, you can write it as 2 and -6, or you can write it as, 2, 0. I was thinking of zeros and I put it in the wrong spot. 2, 0 and -6, 0. Because these are points on the x-axis, so they have a y value of 0. And those are also what I call the roots. So this is what we solve for when we solve any of our quadratic equations for x. We are finding what the roots are, where that parabola touches or crosses the x-axis. Okay, now this particular one wants an increasing domain. Increasing means your y values are getting bigger as your x values go left to right. So we always look left to right, and it's always based on the x value of the axis of symmetry. So from here, notice that as I go left to right, my y values are getting bigger. So that means that when x is greater than or equal to -2, I'm on an increasing interval for my y values. All right, so pause it here. Try 5 and 6 with that same information using what I just did. Remember, axis of symmetry is an equation. Remember, vertex is a point. Remember, circle, max, or min. Roots can be either just the x values in French curly braces or each of the points of the graph touching and crossing the x-axis. And the increasing domain is for each of those where your y's are getting bigger. Okay, so what are your x's doing while your y's are getting bigger? And it always has to do with the x value of the axis of symmetry. So we'll pause it here and go ahead and try that. All right, guys, take a peek. See how we did? Make sure you can see my second root over here. The graphing calculator is just blocking it slightly. Okay, let's look at the next round of stuff. These are the things that will be on your test. Okay, so here we are asked to graph the parabola and state the information below. So this time the graph is not provided for us, so we need to come up with the table of points. So we've got to make sure anytime we graph a parabola from our graphing calculator, we write down a table of points. Now, notice neither of these has a domain limit. So I am just going to graph the points that actually fit on my 10 by 10 grids that I'm given. And let's just plug into our graphing calculator. So y equals -x squared minus 4x plus 7. Press graph to see it. It does look like we're just going to have irrational zeros. It also does look like our vertex is a little bit higher than we can see on a 10 by 10 grid. So we'll look at that in a second. So let's see. Second and graph gets us our table of points. And so we know we need it to be kind of in the negatives for our points. Oh, yep. Look at that. That axis of symmetry is x equals -2. So the vertex is right 1 point above a 10 by 10 grid. So you know what? That'll be fine. We'll get that in there. But it looks like -6, -5 fits. Then -5, 2. And then we get -4, 7. Yep. So roots are between here and here. And since we don't have an integer root, we're going to call them irrational when we have to answer that in a second. -3, 10, -2, +11, and then -1, 10. So we're turning back around. 0, 7. Well, that makes sense because the last number in standard form here is 7. So there's my y-intercept, right? And then 1, 2, and 2, -5. So let's get those points on there, plotting points. -6, -5, -5, +2, -4, +7, -3, +10, and then right above the graph here is that -2, 11, and then we're going to turn back this direction and notice that we kind of have matches up on each side back this direction. Connect, and it is a curve up here. Oops, my point was just slightly off. So see how that was just slightly off? So I just have to fix that. There we go. So just have to fix that. That's at 2. So that's my 2, -5. I had it at 2, -3, -5 for a second there. Fixed it up though. Don't be afraid to fix it. And then I have to put my equation on it. Y equals -x squared minus 4x plus 7. So now what we're going to do is we're going to state the axis of symmetry, which is x equals -2. And we can tell that just by looking at the table of points. Our vertex is -2, 11. That vertex is a maximum, so I'm just going to write it down next to it. And I knew that just from looking at the -x squared anyway. The roots, here the zeros, we're going to write down irrational because this is not a factorable quadratic and I didn't have integer roots given here. So there were two kind of indications we weren't going to have integer roots. And then the last thing was the domain for decreasing. So as y is getting smaller, what's our domain? Well, it always centers around the axis of symmetry value. So when x is greater than or equal to -2, our y values are getting smaller because for both of these, that's what I'm looking for this time is smaller y values. So I will pause right here and have you do the same stuff on number 8. And again, just look at your paper and make sure you know what each line A, B, C, and D is. When you do the vertex, include max or min just to be safe, right? And we will be right back with an answer. Okay, algebras, check those answers. Let's see how we did on that one. Because your 2 is your value in front of your x squared, you have a narrower parabola than usual. Okay, so you can see that it is definitely quite narrower than this parabola that had just a -1 in front of its x squared, right? Because as the a value increases in size, the parabola narrows, right? As the a value decreases in size, it widens. And so one of the things that we knew to kind of look for, oh, I'm sorry, I forgot to also put minimum here because our vertex here was a minimum value. And I was just stating that it also happens to be the y-intercept with this particular graph because you just have -6 at the end. There is no b value. So your y-axis is your axis of symmetry. And when that is the case, that means that your vertex is also your y-intercept. Okay? Little things like that that you kind of start to get a pattern for. So, okay, given this function, rewrite f of x in vertex form by completing the square and then state if it is a maximum or a minimum. Well, actually, we have done one of these. We've done a few of these in the vertex lesson since we had 2 days talking about it. But if you don't like the f of x and you just want to do y equals to do this vertex form, that is perfectly acceptable. Remember, the deal with vertex form is you're trying to make the binomial squared on purpose so that you can pull the axis of symmetry and vertex from that binomial and whatever number is outside of it. Now, before I can complete the square, I need my x squared to be just with a positive 1. So I am going to divide everything by -1, which changes all of these signs. And now this is not the C term I want. So I am going to bring this over here. So I've got 9 minus y equals x squared minus 8x plus blank. Those have canceled. Move that guy over. And then I also want a plus blank over here because whatever I do to one side of the equal sign, I have to do to the other. -8 divided by 2 is 4, and 4 squared is 16. So that is my value on my blank. So now I have purposefully created a perfect square trinomial that factors to become x minus 4 in parentheses squared. Over here, these are numbers that add up. I get 25 minus y. And now I just work to move those things back with my squared binomial. So I start by subtracting 25 over. So I get -y equals the binomial x minus 4 in parentheses squared minus 25 at the end. And then since I've still got this negative in front of the y and I have to move that back over because my a values have to match at the end, I need to now divide everything by -1, which means that y becomes positive. It means that in front of the binomial squared, I put a little negative. And in the back, -25 divided by -1 is a positive 25. Now, because of the negative in front of the x squared anyway, I know that this is a frowny face parabola so that the vertex is a maximum. So I need to state the vertex, which is 4, 25, and that it is a maximum. Those are my answers. I needed vertex form. I needed to state the vertex. I needed to state max or min. I probably could have circled the maximum in the problem too, but former regents question right there. Okay, well now we've got a more real life scenario going. So here we are with a rocket being launched and modeled by this function. So I'm just going to use my graphing calculator to plug that in. So in y equals, I'm going to type in -16x squared plus 96x. Okay? And this is what I would normally press graph to see, but those are way too big of numbers for me to see anything on my graph. So I'm going to press second and graph instead to get to my table. Now, since this is a real life scenario with time, I need to start with time at 0. I'm not going to have negative time and I'm not going to have negative height. So we're talking only first quadrant. So there's a natural domain that occurs here. Okay. So now what I'm looking at is these points being the time in seconds and the height in feet. Yep, feet. Had to reread real quick. Of the rocket at these times. Now, what are the zeros here? Well, that would be the y-intercept / ground that the rocket is launched from. And then back here is the other root or 0 that is the ground the rocket lands back on. Okay? So find the time it takes for the rocket to reach the maximum height. Well, that would be 3 seconds. And you can also see that right here. 3 seconds at the maximum. Right? Find the rocket's maximum height. We already said 144 feet. Find how long the rocket was in the air. How many seconds pass? 6 seconds. We'll count from ground to ground as in the air, right? What are the zeros? 0 and 6. And what is their meaning? The zeros are the times when the rocket is on the ground. There we go. Nice real life scenario for you. And again, we had the graph here. We probably could have seen these values, but it is nice that they gave us the equation that we could plug into our graphing calculator and really have them in our face as well, value wise. So we weren't making silly mistakes on the graph. Okay. Continuing system and a real nice big graph to graph that system on. I just want to see if I have another system coming up for you so that you can do one and I can do the other. Yes, I do. So let's see. You do this one with the nice big graph. So you're about to do number 11 after I do number 12. So let's do this system together. This is more of a real life scenario system and a little bit bigger numbers. So I'll do this one with you and the other one will be very basic and straightforward general system. So here, projectiles are fired vertically into the air and have heights that are quadratic functions of time. A projectile is fired from the top of the roof, its height. Oh, this first one is the quadratic. A projectile is fired from the top of a roof, its height in feet above the ground after t seconds is given by this function. So there we have it. Evaluate h of 0, which means evaluate time of 0, using proper units. Explain the physical significance of this, which actually, since we read the problem, we already know. And then B, create a graph of this and model this bird's path. So why don't we actually kind of skip ahead to B and C and get things on the graph so we can also visually see what the significance is of h of 0, okay? And of course, we do know that t here is time in seconds, and notice how they've got it scaled where this would be half a second, and this is 1.5 seconds, and this is 2.5 seconds. Okay, so we've got it scaled that way as well. So let's get our parabola on here. And remember that since this is a real life scenario, we know that our x has to start at 0 for time. Okay, so we already kind of know that. It's already innately in there for us. So y equals, what was it? Negative 16, times. Okay, so I can leave this, but let's delete all the stuff behind. Oh, well, let's just press clear and delete it all. Negative 16, front parenthesis, x minus 2, and then end parenthesis squared, and then plus 144 at the end. All right, so I'd normally press graph to see it if it were reasonable numbers, but it's not. So second in graph gets me to my table that, of course, starts off right up here at 0, 80. Okay, so 0, 80, and then 1, 128, and then 2, 144, 3, 128, 4, 80, and 5, 0. Oh, interesting. There's only one root here. Our other root would be before our time had started. And that's because this being our h of 0, so our height at 0 time is 80 feet in the air. Our height at 0 time is 80 feet in the air. Think about that. That means that the rocket was launched from 80 feet in the air. Okay, that's what was going on here. So let's write that down for A before we move too much further, and then we'll get all that good stuff on the graph. So h of 0 equals 80. And if you wanted to do it in your graphing calculator on the home screen, it would just be negative 16 times 0 minus 2 in parentheses squared plus 144. And when we figure that out, we get 80 as our output. And that means that's the matching y value when our x value is 0. Okay, I'm just going to go back to my table over here. So h of 0 equals 80. This means our projectile was launched at an initial height of 80 feet. Okay, that's what that means. That y-intercept value is the initial height when the projectile was launched. So now let's graph it. So 0, 80, let's see. So this is 50, 60, 70, 80, 90, 100. So we know our scale is by tens. So there's 0, 80. 128. So this is 120. This is 130. So a little bit closer to 130. 2, 144. So this is 140, almost halfway up. 3, 128. Well, now that you know that, you can kind of match up horizontally. And then 4, 80, back up to where we started height-wise. 5, 0, well, there is the ground. So let's connect, and this is our projectile. Now, B of T is our bird, and the bird is launched at the same time, or starts flying, I should say, at the same time as the projectile is launched. The bird starts at 40 feet high. How do I know that? Because my y-intercept is 40. What's my slope? 10 over 1, right? So each move up this way is 10. And then if I want one move, I have to go all the way over here. So up 10, right 1 is what I'm looking at. So be careful on your scale. See that? And we get that intersection point. So since each of these is worth 10 on this side, up 1 block is up 10. Right 2 blocks is over 1, or right 1, as you know, I say it. Over doesn't give me a proper direction. Now I've definitely got enough points to connect, and there is my flight of my bird with a nice solid intersection point right there. When will the bird and projectile obtain the same height, and explain how you arrived at your answer? H of t equals B of t when t equals what? 4 seconds. So, word-wise, at 4 seconds, the projectile and bird are at the same height because their y values are both, what was this? 80? Yep. 80 feet at 4 seconds. I even laced in what was actually going on in the problem there, right? So now I'm just going to label H of t and B of t, and that's plenty to label on those because we have different names for those two functions. So that's plenty there. And I'll just circle and label that intersection point. Why not? Red and blue makes purple, so 480 was the intersection point. Okay, last thing I'm asking you to do, pause it so that you can do number 11. That is just a basic system. It's not a real life scenario occurring. So you'll use the graphing calculator to find the points for the parabola. And since this is a 20 by 20 grid, you're going to be able to fit a lot of points on the parabola and the line. Graph what fits. And the reason I say that is because that line will cover a lot of ground. And if you just pick points for your parabola that you like and are comfortable with in the 10 by 10 range, you might miss an intersection point. So be very careful about that as you move with this one. Okay, so pause it, Get this going. That's our last one. We'll come back and we'll finish. Okay, algebra crew, there it is. So I didn't have a domain limit here. So I've got arrows on each end of the line and the parabola. The line I used a straight edge to draw, of course, and used my slope of 3/1 and my y-intercept of 0.5 as my starting point. Then with the parabola, I plugged it into my graphing calculator and got the table of points that fit. Again, I knew I had a little bit more space to work with because I'm on a 20 by 20 grid instead of a usual 10 by 10 grid. So I'm really glad I paid attention to that and stated something to you about it, because 314 is one of the two intersection points. And we may not have noticed that if we were just on the 10 by 10 grid, but we had more space to pull both up. All right, so we were in good shape. So yeah, there we are. All right. Well, guys, this has been your Chapter 11 exam review. Please let me know if there is anything from this that you need. I will, of course, scan the answer key so that you can see it, and anywhere else in a little more detail as far as my my work goes. I just remembered that should probably say algebraically, but since it doesn't, don't worry about it, right? This should probably say algebraically down here. It doesn't. So graphically, you solved that. You did it already. You're cool. All right, guys. Good luck on your Chapter 11 exam, and I shall be seeing you very soon, my dear algebra friends. Bye.